Hello, my dear students. Today we are going to present the benzene compounds and we are going to discuss the nomenclature of the mono and disubstituted benzene and trisubstituted benzene. We are going to discuss the physical and chemical properties of benzene and the detergent industry. So let us start. Benzene, which has molecular formula C6H6. The structure formula of benzene. In 1931, the German scientist Keckel discovered its hexagonal cyclic shape, which contains alternating single and double bonds. As the following shown on the screen, the structure formula of the two rings of the benzene, where the double bonds are present in alternating with the single bond, has two forms. But actually, the benzene has the following structure formula, which means this ring means indicating that the 6 electrons of the pi bonds are delocalized at certain carbon atoms. Now we are going to discuss the preparation in industry from coal tar. Here, during destructive distillation of coal, which means heating in the absence of air, it decomposes into gases and liquids. The most important of these liquids is heavy black substance known as coal tar. By fractional distillation of coal tar, we obtain benzene at 80 till 82 degrees Celsius. The second way for preparation of benzene is from aliphatic petroleum derivatives from normal hexane. Normal hexane is passed at high temperature on surface of platinum as catalyst. This method is called catalytic reforming method. As the equation proceeds on the screen, CH3, CH2O4, CH3, normal hexane. In the presence of platinum and heat, it gives benzene C6H6. The second point here, the polymerization or trimerization of acetylene or ethine. The polymerization or trimerization of acetylene takes place by passing ethine vapor in red-hot nickel tube. As the equation proceeds on the screen, 3 molecules of ethine in red-hot nickel tube gives benzene. The third way for preparation of benzene is from phenol. By passing phenol vapor on the surface of hot zinc powder, which reduces phenol to benzene. As the equation proceeds on the screen, phenol, zinc powder, gives benzene and zinc oxide is produced. The preparation in lab from dry distillation of sodium benzoate with soda lime. My dear student, you know the soda lime from preparation of methane, which is mixture of caustic soda, which is sodium hydroxide and the calcium oxide. Here we are going to use sodium benzoate as a starting material for preparation of dry distillation of benzene that forming benzene. Here the sodium benzoate by dry distillation, it gives benzene. Here the sodium benzoate reacts with caustic soda, sodium hydroxide, in the presence of calcium oxide, quicklime, as drying agent and reduce the melting point of the mixture. It gives benzene and sodium carbonate is produced. Now we are going to discuss the nomenclature of benzene derivatives. The name of monosubstituted benzene. The monosubstituted benzene, its name is derived from the name of the atom or the group which is attracted to the benzene ring followed by the word benzene. As shown on the screen, the nitro group is attached to the benzene ring. so its name it will be nitrobenzene. Here the chlorine atom attached to the benzene ring, which is called the chlorobenzene. We have given reason in this point, my dear student. When a group is introduced into the benzene ring, only one compound is formed. Because the 6 carbon atoms are similar, and so the entering atom or the group attacks any carbon atom. For exercise, the nomenclature of some aromatic compounds. Here is diphenyl, which 2 benzene ring joined by single bond. Here the longest chain is 3 carbon atom, so it is called propane, the root name, and the benzene ring adds the carbon number 2, so it will be 2-phenyl propane. The name of di-substituted benzene. The directing group which are going to name the di-substituted benzene. When a second group is introduced in the benzene ring, there are 3 probabilities for the replacing the hydrogen atom called ortho, meta, and para. As shown on the screen, if A is the first group in the benzene ring, so the position number 2 and 6 are ortho positions, and the positions 3 and 5 are the meta positions, while the position number 6 is para position. Here, if the second group B is in the number 2 or 6, it is ortho. Number 3 or 5, it is meta. In the number 4, it will be para. This reaction depends on the attached group A. First, we are going to discuss the ortho and para directing groups. If the alkyl group is the first group, so it is ortho and para directing group, and also hydroxyl group, and also halogen atom as fluorine, chlorine, bromine, iodine, and the amino group, which is NH2. For example, halogenation of toluene. Here the toluene is methyl benzene. When react with chlorine, the presence of iron, it gives the 2 products, orthochlorotoluene or parachlorotoluene. We can name these molecules by IUPAC name. It will be 2-chlorotoluene and 4-chlorotoluene. The meta-directing group, which is aldehyde group CHO, or ketonic group, which is carbonyl group CO, and the carboxyl group, which is COOH group, and nitro group, which is NO2 group. For example, the halogenation of nitrobenzene. Here the nitrobenzene, when reacts with chlorine in the presence of iron, it gives metachloronitrobenzene and HCl gas is produced. Here, my dear student, if you are going to name it by IUPAC name, it will be 3-chloronitrobenzene. The name of the tri-substituted benzene. If the benzene is tri-substituted, the carbon atoms in the ring take numbers, where each carbon atom attached to group or atom takes the same number. Then nomenclature is arranged according to the alphabetical letter. For example, as shown in the diagram here, we are going to numbering the benzene ring. To get the substitution to the lowest possible number can be obtained for the substitutions. So this compound will be named 4-bromo, 1-chloro, 2-nitrobenzene. My dear student, notice that the nomenclature by the IUPAC system considers only the numbering of the benzene ring. Now we are going to discuss the physical properties of benzene. It is transparent liquid, immiscible with water. It has pleasant smell. Its boiling point is 80 degrees Celsius. It burns in air with a black smoky flame. as its molecule contains large number of carbon atoms. Now, my dear students, we are going to discuss the chemical properties of benzene. The benzene reacts by two kinds of chemical reaction: addition reactions and substitution reactions. We are going to discuss them in details. First, we are going to discuss the addition reactions. The first kind of addition reaction is the hydrogenation reaction, which means the reaction with hydrogen gas. C6H6, which is the benzene, reacts with hydrogen under pressure and temperature in the presence of catalyst to give hexahydrobenzene or cyclohexane. As shown on the screen, benzene reacts with hydrogen in the presence of heat, pressure, and catalyst. It gives the C6H12, which is cyclohexane. The second type of reaction is halogenation reaction. Here, benzene reacts with chlorine or bromine in the direct sunlight to form hexahalocyclohexane. As shown on the screen, benzene reacts with chlorine in the direct sunlight to form an insecticide called hexachlorocyclohexane or called gamexane. As the equation proceeds on the screen, the benzene reacts with 3 moles of chlorine in the presence of ultraviolet radiation, forms gamexane or hexachlorocyclohexane. Now we are going to discuss the substitution reaction. Here, the halogenation reaction. Here, the benzene reacts with chlorine in the indirect sunlight in the presence of iron 3 chloride as a catalyst to form chlorobenzene. Here, the benzene reacts with chlorine in the presence of ultraviolet radiation and in the presence of iron 3 chloride, giving chlorobenzene C6H5Cl, and HCl is produced. Now, my dear student, we are going to discuss the halogen derivatives of the aromatic compounds. The aryl halides are used as insecticides. The DDT, dichloro diphenyl trichloroethane, that molecule is shown on the screen, that CCl3CH attached to 2 benzene ring and the chlorine in the para position. Here is molecule dichloro diphenyl trichloroethane or DDT. We have given reason in this point, my dear students. The DDT has poisonous effect. Due to the presence of group CHCCl3, which dissolves in fatty tissues of the insects and kill it. We have given reason in this point. DDT was called the ugliest compound. The reason for that because of its environmental problems, which appeared during its usage. My dear students, we are going to talk about the second type of substitution reaction. This is alkylation, which is called Friedel-Crafts reaction. Here, the benzene reacts with alkyl halide, where the hydrogen atom of benzene ring is replaced by an alkyl group, forming alkyl benzene. This reaction usually takes place in the presence of anhydrous aluminum chloride, AlCl3, as a catalyst. As the equation proceeds on the screen, C6H6 plus CH3Cl in the presence of anhydrous aluminum chloride and heat, it gives C6H5CH3, which is toluene or methyl benzene, and removing HCl. The third type of substitution reaction is nitration reaction. Here the benzene molecule C6H6 reacts with nitric acid in the presence of concentrated sulfuric acid, where the hydrogen atom of benzene ring is replaced by nitro group, which is NO2 as the following animation show. We are going to add the conc nitric acid in the presence of sulfuric acid to the benzene. Here we are going to show the replacement of the hydrogen atom of the benzene ring by the nitro group to give the nitrobenzene. Then the nitrobenzene is formed, releasing one molecule of water as a product. As the reaction here proceeds, and the nitrobenzene is formed. My dear student, here as shown, that must be in warm heating, here 50 degrees Celsius. As the equation proceeds on the screen, the benzenes react with conc nitric acid in the presence of conc sulfuric acid at 50 degrees Celsius. It gives nitrobenzene C6H5NO2 plus H2O. Here, my dear student, we have good reason in this point. The polynitro-organic compounds are very explosive. The reason for that because their molecules contain their own fuel, which is carbon, besides oxygen, which is oxidizing agent. So, burn rapidly, and also due to the weakness of the bond between nitrogen and oxygen, NO, to form two strong bonds between carbon and oxygen, CO, in carbon dioxide, and the bond between nitrogen and nitrogen in nitrogen molecule, so a great amount of heat and gases are produced accompanied by explosion. Now, my dear student, we are going to discuss TNT, which is 2,4,6-trinitrotoluene. It is one of the explosive nitro-organic compounds, which was produced by millions of tons through the Second World War and is still produced until now. This compound is prepared by the reaction between toluene and a mixture of concentrated nitric acid and sulfuric acid by ratio 1:1. As the reaction proceeds on the screen, the toluene, which is methyl benzene, undergo nitration reaction. It reacts with 3 molecules of nitric acid in the presence of concentrated sulfuric acid and 50 degrees Celsius. It gives the 2,4,6-trinitrotoluenes, what we call TNT, as shown on the screen. Now we are going to discuss the next substitution reaction for benzene, which is sulfonation reaction, which is a reaction with concentrated sulfuric acid. In this reaction, the hydrogen atom of the benzene ring is replaced by a sulfonic group. This sulfuric acid group, SO3H group, is replaced the hydrogen atom of the benzene ring. As the screen shows now the equation of the reaction, benzene plus sulfuric acid warm and concentrated. Here one hydrogen atom is replaced by the sulfonic groups SO3H group, so it forms benzene sulfonic acid, and one water molecule is produced. Now, my dear student, we are going to discuss the detergent industries. It depends on the aromatic sulfonic acid compounds after treatment with caustic soda to obtain the water-soluble sodium salt. As the equation proceeds on the screen, we have aromatic sulfonic acid or alkyl benzene sulfonic acid reacts with sodium hydroxide as it forms sodium salt of alkyl benzene sulfonic acid as it's shown on the screen, and water is produced. Here, my dear student, the molecule of the detergent is composed of 2 parts, head and tail. Here, the tail is a long chain carbon which alkyl benzene radical, which is hydrophobic. It means it doesn't dissolve in water. And the head, it is ionic group, which is sodium salt of sulfonic acid group, which is hydrophilic, which means soluble in water. Here, how can the detergent remove the spots and dirts? When the detergent is dissolved in water, their molecules arrange themselves such that the hydrophobic tail of each molecule is directed towards the dirts and textile and adhere with them. Then the hydrophilic head is directed toward the water, so the detergent surrounds dirts completely. So, with any mechanical rubbing, the textile and the dirts are repelled out with each other, as the following animation shows. As shown on the screen now, here is the detergent molecule, the tail, which is hydrophobic, and the head, which is hydrophilic, and the tail is carbon alkyl chain, and here the head, which is ionic chain. Here, when the water molecules interacting with the detergent, we find that the detergent here as the oil, as the dirt here, and the textile here, we find that the tail of the detergent is directed toward the dirt, while the head directed toward the water. And also as a textile, the tail is directed toward it, and the head is directed toward the water. So with any mechanical rubbing, the detergent action starts, and like heads repel with each other, and the dirt will be removed. So the dirt will be removed because both of them are covered with the positive head of the molecule, which are like charges, so repel with each other. Now, my dear students, we are going to discuss some questions on it. The first type of question is to choose the correct answer. Phenol is reduced by zinc and produces what? Normal hexane, or cyclohexane, or zinc phenate, or benzene. If you think about it, my dear student, you will find the answer. It will be normal hexane. No, it will be benzene. Why? Because, my dear student, when the phenol reacts with zinc, the zinc takes oxygen from the phenol, so it forms zinc oxide and the benzene is formed. Next point. The product of halogenation of nitrobenzene is what? Is it orthochloronitrobenzene, or parachloronitrobenzene, or orthonitrochlorobenzene, or metachloronitrobenzene? If you think about it, my dear student, we are going to start with nitrobenzene, and on adding halogen on it, we find that the nitro group is meta-directing group, so it produces only the metachloronitrobenzene, as shown on the screen. The next point, catalytic reforming method of normal hexane produces what? Normal hexane, or cyclohexane, or zinc phenate, or benzene. Yes, my dear student, if you think about it, yes, it will be benzene, as it is the way from preparing benzene from aliphatic hydrocarbons. Next point, benzene may react by substitution only, or addition only, or elimination, or addition and substitution. If you think about it, my dear student, yes, it will be addition and substitution. Next point, dry distillation of sodium benzoate with soda lime produces what? Is it normal hexane, cyclohexane, zinc phenate or benzene? If you think about it, my dear student, when sodium benzoate reacts with sodium hydroxide in the presence of calcium oxide, that the mixture of sodium hydroxide and the calcium oxide is called soda lime. It produces, yes, benzene and sodium carbonate as secondary product. The number of hydrogen atoms in alkyne having 5 carbon atoms is what? Is it 5, 8, 14, 12? Yes, if you think about it, it will be 8. Next point, when water dropped on calcium carbide gas, what is produced? Is it methane, ethane, ethene, ethane? If you think about it, yes, the answer it will be ethane or acetylene. Next point, the number of carbon atoms in alkyne having 10 hydrogen atoms is what? 14 or 7 or 6 or 5? If you think about it, it will be 6. Next point, saturated cyclic hydrocarbons which composed of 3 carbon atoms or more are called what? Is it alkanes, cycloalkanes, alkynes, or aromatic compounds? Yes, the answer it will be cycloalkanes. Next point, cyclohexane is an example for what kind of hydrocarbon? Is it unsaturated aliphatic or saturated open chain aliphatic or aromatic or saturated cyclic aliphatic? If you think about it, yes, it will be saturated cyclic aliphatic. The value of the angle between the bonds in cyclobutane is what? Is it 109.28 minute or 107 or 6 degree or 90 degree? If you think about it, yes, it will be 90 degree. My dear students, we have reached our program today. I hope you understood all the points that we discussed today. So, till we meet again, my best wishes for you.